Hey everybody, today I'm going to run you through the first part of Chapter 4 on the preliminary Maths in Focus Extension 1. As I've said before, this chapter doesn't contain too many surprises. I've emailed you a copy of the syllabus. It would be a good idea to read through the section on plane geometry, that's from pages 22 to 31. Look carefully at the worked examples and make sure that you can replicate the reasons. Carefully read through the section on notation. You need to be able to use this language in your proofs. Make sure that your statements are concise and to the point. I've just taken a few snippets here. The first section starts talking about all the standard notation. They are pretty fussy about using abbreviations, so you have to be careful about some of the abbreviations, but if you just follow the examples and look at the sort of things they use for abbreviations, you'll be fine. Here's a simple numerical, the first simple numerical example. Have a look how concise their explanations are. Okay, in brackets, just using very concise language. The first section is on types of angles. These should be familiar to you. So the first one is the acute angle. That's angles from 0 to 90. Right angles, 90 degrees. And they talk about complementary angles. Complementary angles are angles whose sum is 90. And it's always one of those tricky things to remember. What's it, complementary, supplementary? I always struggle with that, but someone said to me once that one way to remember it is right to give a compliment. So right to give a compliment. That's a good way to remember it. Obtuse angles, that's between 90 and 180 degrees. Straight angles, reflex angles, and angles of revolutions. That brings us to vertically opposite angles. Now, vertically opposite angles are equal. Okay, just think about this as like a pair of shears or a pair of scissors, handle on that end, blade on that end. As you squeeze them together, so the blades come closer together, as you open it up, they open up, and the angles are always equal. So that angle there, ACE, equals angle BED. Similarly, the angles at the top and bottom are also equal, so AED equals angle CEB. In the book they've done a proof on this, and this is just based on straight lines. Fairly simple proof when you have a closer look at it. Okay, now so it's you could go and have a look at exercise 4.1. These questions are very straightforward, but make sure you pay attention to the reasons. So just cherry pick a few questions, have a go at the harder ones at the end. Make sure you can do those. Make sure you can replicate the reasons that they give. Now sometimes you might take a slightly different course to the way the book's done it. That's all right, as long as you end up in at the same spot. Next section is on parallel lines. This material would have been covered in around about year 7 or 8, but we've come back to it quite a lot. But parallel lines, okay, we're talking about transversals here. A transversal, that's that line there. When it cuts two lines, it forms pairs of angles. And when the lines are parallel, these pairs of angles have special properties. So the first one is alternate angles. Okay, the angles are on alternate sides of the transversal. And if the two lines are parallel, then the alternate angles are equal. Now there are two pairs of alternate angles. They've only marked one pair there. The ones on the other side are also alternate angles. In junior school you probably might have called them Z angles. Corresponding angles. Now when you have a transversal cutting across a pair of parallel lines, you get a pair of corresponding angles, and corresponding angles are equal. In fact, in a transversal there are actually four pairs. So the red ones that I've marked are the first pair, and then if we go across to here, and that angle there are corresponding angles. Then going on the other side of the parallel line there, that angle is equal to that angle there. And then the last one is that angle and that angle there. So there are four pairs of corresponding angles and they are equal. Co-interior angles, C angles as we probably used to remember them. Co-interior angles are supplementary. Their angles sum is 180 degrees, and once again there are two pairs. Okay, so that pair there are supplementary, and the pair on the other side are also supplementary. Now with parallel lines, this is what we call the converse. So if you see alternate angles are equal, then the converse of that is that the lines must be parallel. Similarly, if you see a pair of corresponding angles are equal, then the lines that they cut are parallel. And for co-interior angles, if they are supplementary, then the lines are parallel. Okay, so that's just the converse of the other ideas. And the last part of this is that if you have two lines that are parallel to a third line, then the three lines are parallel to each other. Okay, so that's just sort of stating the obvious really, isn't it? Okay, so now you are ready to go on and do exercise 4.2. Once again, just keep an eye on the on your notation, on the way you explain your proofs. Keep them concise and to the point, and as I said, cherry pick some of the harder ones at the end, and you should be fine. The next section is on types of triangles. Okay, so we've got scalene triangles. That is where no two sides or angles are equal. A right angle triangle has a right angle in it, and in a right angle triangle that side's called the hypotenuse. An isosceles triangle, okay, an isosceles triangle have two equal angles, sometimes called the base angles, and the sides has two sides that are also equal. Equilateral triangles are where all three angles are equal and all three sides are equal, and therefore the three angles then equal 60 degrees each. Okay, acute angled triangles, that's where all the angles in the triangle are acute. An obtuse angled triangle contains one obtuse angle, can't contain more than any more than one. Now, one of our founding notations about triangles is that the three angles add up to 180 degrees. In the book they've done a proof using parallel lines. Now, so if you have a triangle ABC and you have another line parallel to the base, then that angle there, B, is equal to that angle there, which is also B, and they are alternate angles. Angle C equals that angle over there, which is the same size as C. So if that's B, and that's C, and that's A. A plus B plus C equals 180 degrees. Okay, so that's just the basic proof for parallel lines. Exterior angles of triangle. Basically, exterior angle of a triangle is equal to the sum of the two opposite interior angles. So x plus y is equal to z. The proof in the book is done it using parallel lines. An alternative way of doing this is to say that if that was, say, A, if that was B, and that was C, those three angles add up to 180 degrees. And in a straight line, you have 180 degrees. So this line from B to C produced to D is 180 degrees. And that angle there is C. So therefore, that part there has to be A plus B, because A plus B plus C make 180 degrees. And that's finished. That's the last part of exercise the section on exercise 4.3. So now you can go and have a go at those questions, and once again, mainly pick on the harder ones. You should be fine for that.